Hi everybody again. Here's part 3 of the Physics Final Exam Review answer key. We're starting on number 7 here with spring scales. The left scale reads 17 newtons. How many grams is the hanging mass? So I'm just going to draw a free body diagram for this. We've got a 40-degree angle on the right. Got a 25-degree angle on the left. And we're told the tension on the left is 17 newtons. We got a force of gravity pulling down that we don't know, and we're trying to figure that out and then get the mass from that. Alright. Since we know there's only two forces left to right, those two forces need to be the same. The system is in equilibrium. And our two vertical forces are going to add up to the force of gravity. So if we can find the two y components and add them up, that'll give us the force of gravity. So using 17 sine 25 and 17 cosine of 25, we can get our two components on the left triangle. That would be 15.4 newtons on the bottom and 7.18 newtons on the y-axis, or y side. We already know that has to be the same as the x component on the other triangle. And then we can use tangent to get the y component. That would be FTY over 15.4. So solve for FTY and you get 12.93. So for FG, we can just add our 7.18 plus the 12.93, and we get a force of gravity of 20.11 newtons. Divide that by 9.8 to get the mass, and you'd get 2.05 kilograms. And there are 1,000 grams per kilogram, so that's 2,050 grams. On to the golf shot. It gives you the velocity of the ball, and we're going to go a 75-degree angle. And we have to answer various questions. So first off, I'm going to find the x and y components. So the x component is 12.16. The y component is 45.4. First question wants to know how high does the ball go. So this is when you set your final y velocity equal to 0. You can use your VF squared equals VI squared equation. So 0 equals 45.4 squared plus 2 negative 9.8 delta y. Solve for delta y. The ball goes 105.2 meters high, which is really high, but what are you going to do? B, how long is it in the air? So if it starts on the ground and lands on the ground, your delta y is 0. So I'm going to use delta y equals VIYT plus 1/2 AT squared. So 0 equals 45.4 T plus 1/2 negative 9.8 T squared. Move one to the other side, so I got 4.9 t squared equals 45.4 t. Divide by t and then by 4.9. The time in the air is 9.3 seconds. Could have also found the time to the highest point and doubled it, because it's going to be a whole parabola when it lands on the ground. C wants to basically know the range, so I'm going to take my Vx, which is 12.16, and multiply by the time. And that gives us 112.7 meters away. Okay, next up we've got a seesaw problem. It says, before finals, you and a few other cool people decide to take a break from studying and play on a seesaw you built. Where should Pat sit to balance the seesaw? So right now there's too much weight on one side. We need to balance that on the other side. So Pat's going to need to sit somewhere on the left-hand side there. So remember, this is a torque problem. Torque is R times F sine of theta. For seesaws, you don't really have to worry about theta, because people are going to be sitting perpendicular to the seesaw when it's balanced, so you don't have to worry about 90-degree angle. So Scott here is creating clockwise torque, Zach creating clockwise torque, Kelsey's creating counterclockwise torque. And since Scott and Zach's side is down, we need Kelsey's side to go down. So Pat is going to have to be somewhere on the left-hand side over here, creating some more counterclockwise torque. So Pat's mass is 75. So his R you don't know, but his force would be 75 times 9.8. Add that to Kelsey's torque. So her distance from the fulcrum is 1 meter times mass 60 times 9.8. Zach, his radius from the fulcrum is also 1 meter, mass 113 times 9.8 for a force, plus Scott. Scott is 3 meters from the fulcrum, mass 100, 9.8. Now you can divide all terms by 9.8 since there's a 9.8 in all of them. So you've got 75R plus 60 equals 113 plus 300. So 75R equals 53 when you subtract the 60. And then 353 divided by 75 gives you 4.7. So Pat needs to sit 4.7 meters to the left of the fulcrum. B, a lug nut on a car is tightened to a torque of 1100 Newton meters using a 31 centimeter tire iron. What's the minimum force required to loosen the nut? So torque is R times F sine theta. When it says minimum force, we're using a best angle, so 90-degree angle. So 1100 is the torque. 31 centimeters is 0.31 meters times F times sine of 90. Solve for F, and you get 3548 newtons. Part C, if you could exert the same amount of force as your answer in Part B, but you were forced to work at a 50-degree angle, how long would that iron need to be? So we still have the same torque, you still have the same force, but now you're solving for R. And your angle is not 90 degrees, now it's 50. So solving for R, you get 0.4 meters long. So it'd have to be about 9 centimeters longer. So that ends the irregular portion of the final exam review. I know there are some Harry Potter questions after this. If I have a minute here, I'll make a video going through those answers. But as long as you got these, you're in good shape. Those Harry Potter ones are a little bit, they're just kind of fun problems to practice if you need more, or if you're looking for more things to try and do. So I'll see if I can put together a video for that. If not, happy studying. Remember, ask Miss Oswald and Mr. Evans if you guys have questions after school.